All right. So yeah, we're starting with 6.5. We're doing 6.5 and 6.6 today, but only having homework on 6.5. All right. And so 6.5 is the last of the conic sections, and it's called 7.5. Yes, thank you. So all those things I said are about chapter 7 instead of chapter 6. But yes. So 7.5 is hyperbolas. Okay. So if you remember what each one of the conic sections are, as far as graphically what's going on. The first one we learned is a circle. Graphically, what is the definition of a circle? All points a given distance from a given point. Okay? What is the definition of a parabola graphically? All points that are the same distance from a point in a line. That point is called the focus. That line is called the directrix. Then, what was an ellipse? It was a weird one. You had two foci, and it's all points that if you add the distance to those 2 points, it's a constant, okay? So like all the points whose the sum of the distance to 2 foci are 7 or something like that, okay? Well, ellipse is very similar, except it is all points whose difference is constant, okay? And we talked about that briefly before y'all went on the break, about how that comes to be. All right. So I'm just going to dive in and teach you the graph of a parabola. Okay. Hyperbola in standard form looks very similar to an ellipse. Okay. There's just 2 ways it can be written. So you can have this. What's the only difference in this versus an ellipse? Right. An ellipse, what's different? If this were an ellipse, what would the equation look like? There's just a plus here. These are both still minuses, but this is a plus. Because in an ellipse, you're adding the 2 distances. In a hyperbola, you're subtracting the 2 distances. Okay, so there's a minus. All right? The only difference is it could also be written like this. What's the difference? You just swapped x and y, okay? On an ellipse, it didn't matter which one was first because you're adding them, right? So one plus another would be the same as the other because addition is commutative. So it didn't matter if a squared was with x or with y. Remember, in fact, I even called it the x radius or the y radius, all right? And a squared for an ellipse was just whichever one was the bigger one, okay? But for here, a squared is the one that's positive, okay? So that could be with x, that could be with y. It's just whichever one is first, therefore the one that's positive, okay? The way you graph it is almost identical to an ellipse, okay? So what you do to graph a hyperbola, first thing is you graph just like an ellipse all the way up to the point where you'd actually draw the ellipse. Okay, so let's let me leave some space here to put the rest of the steps, but I'm going to go over and do an example and do that part of it. Okay, so if I ask you to graph, we'll do this. What now? Well, not yet. You can't. For your notes? Yes. It's over here. Well, it's hard to get to, but it's over here in the bottom drawer. Okay, so walk me through what you would do if this were an ellipse. Anybody? What's the first thing you would do?
It'd be the center.
The center is going to be where?
It's going to be -2, 5.
Right, -2, 5. So you go -2, 1, 2, 3, 4, 5. Okay? Then, what would you do?
And the focus?
No.
It's the measuring.
Right? So, on the x-axis, what's your radius? It's not really a radius, but what do you do? It's going to be the square root of 16, so it's 4. So we're going to go 4 to the right, 1, 2, 3, 4. 4 to the left, 1, 2, 3, 4. Okay, so this is the point -2, 5. This would be the point 2, 5. This would be the point -6, 5. Right? Then what would we do? No. The y-axis, we would go up and down 5. So you go down 5 to here, up 5 to here. This would be the point -2, 10. This is the point -2, 0. Then you would just connect all of those, and that would be your ellipse, right? Okay. So I said do it up until the point where you would do that, okay? So you do that. That's what you would do if it were an ellipse. Since it's a hyperbola, though, instead of drawing an ellipse, draw a dotted rectangle through the 4 points that would be on the ellipse. Okay? So instead of drawing the ellipse, we're going to draw a rectangle, a dotted rectangle through these 4 points. Okay? A dotted rectangle. What are the coordinates of the corners of this rectangle? This one would be 2, 0. This one would be 2, 10. This one would be -6, 10. This one would be -6, 0. Right? Okay. Then draw your asymptotes through the corners. Okay, so that's an asymptote. That's an asymptote. Okay? Now a hyperbola looks like two parabolas that go in opposite directions. Okay? So we're either going to have one that looks like this and this, opening left and right, or we're going to have one opening up and one opening down. Okay? The way you decide is whichever was positive. Your x is positive. So from the center, you're going to go in the x direction to your vertices. Okay? So since x is positive, from the center, you go in the x direction, and these are your two vertices. And it curves and goes closer and closer to the asymptote in every direction. Oh, shoot. Okay, hold on 1 second. I'm just going to hardwire it to the projector instead.